All right, let's dive right in. Today, we're talking about something absolutely fundamental in the blockchain world, smart contract verification. And really, it all comes down to one simple but massive question.
I mean, think about it. The whole point of a smart contract is that it's set in stone. It's immutable. But the code that's actually running on the blockchain, it's just a long string of machine code, total gibberish to you and me. And this creates this huge gap in trust. It's in that gap that things can go wrong, really wrong, like multi-million-dollar exploits. So, how do you really know that a contract is going to do what its creators say it will?
Well, the answer looks a lot like this. This verified stamp you see on block explorers, it's so much more than just a little icon. It's a seal of approval. It's the proof that bridges that trust gap, confirming that the human-readable code you can look at and inspect is the exact same code running on the blockchain. No tricks, no hidden surprises.
So, to really get how we earn that stamp of approval, we first have to tackle the big idea here. What it means to actually trust the code.
Here's the most important thing to get your head around. There are always two versions of the code. You've got the source code, which developers write in a language like Solidity. It's stuff that we can actually read and understand. But then there's the bytecode. That's what the source code gets translated into, and that is what's actually running on the blockchain. Without verification, you're just taking someone's word for it that the two are the same.
And that potential mismatch, that's exactly why this whole process is so critical. So let's talk about why verification really truly matters.
Look, verification isn't just some technical box-ticking exercise. It's a pillar of the whole ecosystem. When you verify a contract, you make the source code public for anyone to see. That means other developers can audit it, look for bugs, or check for malicious code. It builds this massive foundation of transparency and security. Plus, it lets all the developer tools interact with the contract properly. But most importantly, it reinforces that core promise of blockchain, a system where you don't have to trust a person or a company. You can just trust the code.
Okay, so to really understand this, we need to zoom in a little bit on that relationship between the two types of code, the one for humans versus the one for the machine.
And here it is, the official definition. At the end of the day, smart contract verification is just the process of mathematically proving that the source code someone gives you is a perfect one-to-one match for the bytecode that's already living on the blockchain. It's about making sure nothing got changed, nothing was added, and nothing was taken away in that translation process.
This diagram right here tells the whole story perfectly. Over on the left, you've got the source code files. In the middle, you have this compilation process. And all the way on the right, that's the final bytecode sitting on the blockchain. That red arrow pointing between them, that's the whole ballgame. That's verification.
So let's start on the left. Everything begins with these files, with names like mycontract.sol. These are the blueprints, written in the language like Solidity, that a person can actually read and make sense of.
Then, those files get fed into something called a compiler. You can think of it like the gears in the middle of our diagram. This machine takes that human-readable code and just chews on it, spitting out the bytecode, that crazy long string of numbers and letters. That's the only language the blockchain's virtual machine can understand.
And this is the magic moment. The verification service, like on Etherscan, takes those exact same source files, uses the exact same compiler settings, and runs that whole compilation process all over again. It creates a brand new string of bytecode and then compares it, literally bit for bit, against the bytecode that's already on the blockchain. If they are 100% identical, boom, we have a match. The contract is officially verified.
Okay, so we've covered the what and the why. Now let's get practical and walk through the how. What are the actual steps in the verification process?
So it all starts on the developer's own computer. First, they compile their code. This gives them two things, the bytecode we've been talking about and something called an ABI, which is basically an instruction manual for how to talk to the contract. Then they take that bytecode and deploy it to the network, and at that moment, the contract is live. But to the rest of the world, it's still just an unverified black box.
Next up is the public part. The developer goes to a block explorer like Etherscan, finds their contract's address, and clicks that big Verify and Publish button. Then, they have to be super careful and provide all the exact ingredients, the original source code, the specific compiler version they used, the license. Every little detail has to be perfect. They hit submit, and that's when Etherscan does its magic and runs the comparison.
And it's worth pointing out, this whole dance is getting easier and easier. For any developers watching, coding tools like Remix now have extensions that can hook directly into Etherscan and automate a lot of this for you, which is great. It just makes being transparent that much simpler.
So when we zoom back out from all the technical details, what does this all add up to? Well, it's about way more than just code. It's really about building a more transparent future. This quote from one of our sources really just nails it. Every single developer who takes a few extra minutes to verify their contract isn't just building trust in their own project. They're adding another brick in the wall of integrity for the entire ecosystem. They are, in a very real way, contributing to the trustlessness of the whole network for everybody.
And that leaves us with a final, much bigger question, doesn't it? I mean, smart contract verification is the blockchain world's answer for proving code is trustworthy. But as more and more of our world, our money, our cars, even our homes, starts to run on complex code, this question becomes universal. How are we going to prove that all the code that runs our lives is actually doing what it's supposed to? That's a challenge we're all going to have to figure out together.